I'm from TIBCO. We're the guys right outside there with the Mercedes car, and I'm going to be giving a case study on that work that we did with those guys. But I'm going to be covering a number of success stories in AI. Firstly, anomaly detection, recommender systems, and patient diagnosis. Now, there's a bunch of other success stories from AI, and a lot of these follow some similar patterns that we're going to reveal as we go through these success stories. And one of those things is that really to generate value from AI machine learning, you've got to take it to real time. So if you think about every data point begins as a real-time event. Now, we bring those real-time events down to some accumulated storage, like a data lake, where we do analytics on those. And then we find some insights from the analytics, but those insights are perishable. The data are not perishable, they fade in value, but the insights are very perishable. So you really got to take action on whatever it is you determine as an insight from the accumulated data, and you've got to take action, again, on a real-time system. That's how value gets generated from AI and machine learning. Now, if you think about just my AI timeline, back when I was a young guy, I started work at a medical diagnostics company, Becton Dickinson, and we built some AI into an instrument that when you put a blood sample in an instrument in a hospital, we figured out what was the bacteria, and then we plated that out with a number of antibiotics at different concentrations, and we figured out what was the minimum inhibitory concentration to kill the bacteria. And now this aided the doctor to say, I want to prescribe this antibiotic at this concentration in a variety of ways. So it was a combination of a set of rules that determined the bacteria identification, and then it was a machine learning algorithm that figured out the minimum inhibitory concentration of the appropriate antibiotic. So that was way back in the 90s, and then in 2007, I was running the American Statistical Association section on statistical computing and graphics, and Netflix put out a competition at that time, $1 million for someone who could come up with a recommender algorithm for their set of movies. Though this is back in the days where you got the actual DVD mailed to you, and you put it back and sent it back with some rating. And right at the death there, a team from Bell Labs came up with an algorithm that Netflix judged to be significant, and they won the $1 million. And so I covered that as an interview in the journal for the statistical computing section. Now, get into a little bit later on, and I became enamored with iPhone 2, and really intrigued by the fact that I could put all my music on it. So I became a big iPhone devotee. And Shazam, what an amazing app. One of the early apps on the iPhone, hold up your phone for a couple of seconds and you can tell what song's playing. You can go to a club and get all the DJs, underground songs, all that kind of stuff. Pretty magical. So that was a big chunk of time for me there. I then wrote a book in 2012 in the age of knowledge discovery and database as big data was just coming along. And then at TIBCO, we put out our connected intelligence portfolio about 2016, and we started bringing AI into our products and machine learning across our portfolio. And then just today, we announced the launch of Spotfire 10. It's written X, but it's pronounced 10. And there's a bunch of new features in there. We've got a new AI engine that basically finds all the patterns in the data and suggests to you how you might want to build out your analysis. It has NLQ to combine the AI engine with a conversation that you can have with the software to build an analytically informed app. So that's kind of my personal timeline. And I'm going to start off now jumping into the AI success stories. And there's some references I'm going to make to that journey I've been on. So recommender systems and suggestion engines. This is a great success story from AI. And this is started with Amazon. You know, people like you who bought this also bought this, and so we're going to recommend that to you. This is this proposition we're going to make to a similar person, to the original person, and propose this product. You know, these things evolved into finding similar products and proposing those directly. If you bought this, you might also like this. We've seen this at Netflix, as I mentioned, also Spotify. Spotify is awesome. You start off putting in some playlist and you end up in some totally different area that's related to where you started. And I'm always intrigued by how I start off with, say, Roxy Music and end up with Caribou. It's like some journey that Spotify takes you on. You know, Goodreads is another example of this. Now, underneath these recommenders, there's a layer of inference that occurs in the suggestion engine. So, for example, the latent variables that are estimated to decide what Netflix is going to recommend to you, Netflix categorizes the movies into things like, British cooking shows or crime dramas or whatever, and that is the category that's being used to make the inference to put those suggestions in front of you. You don't see those, but that's what's going on behind the scenes. So the recommender systems have been really, really powerful. And one example about the power of these is, I mentioned back in 2007, Netflix did this 1 million competition that Belcore won. Fast forward a couple of years to 2011, and this TV show House of Cards was being pitched around Hollywood. Now, all of the executives back in those days were paranoid. Over the past year, they'd spent $400 million on 113 pilots, and only 13 of those had gone to season 2. Now, everybody wanted to do a pilot. Netflix ran this series through its recommender engine and says, hey, we've got an audience for this. We don't need to do a pilot. So they bought this show back in 2011. It became their very first original series that they produced. And remember, back in these days, Netflix's stated goal, was to become HBO before HBO became us. That was their stated mission. Nice to have a single mission statement like this. And here they were. Their very first original series launched in 2013. They were able to snag it up from their recommender system analysis. And there, 1 month ago, they got more Emmy Award nominations than HBO. So for the first time ever, HBO got less Emmy Award nominations than someone, and that was Netflix. And they also announced that this year, they're spending $8 billion with a B on original programming. So how's that for a success story related to a recommender engine that they outsourced? This was also the beginning of Kaggle. Many other things came out of this original Netflix competition. But look at that. They've been able to generate an $8 billion investment from a $1 million prize that they gave out in 2007. So clearly, recommender systems are a pretty big deal, and they're a huge success story for AI. Okay, now underneath that is a suggestion engine, as I mentioned, and what we've done in Spotfire 10 is to put a suggestion engine as part of our Spotfire recommendation system into the product. So this allows you to, basically, as you bring your data into Spotfire, we are finding patterns in the data through our suggestion engine. We're putting those in front of you in a series of best practice graphics, and all you have to do is make a few mouse clicks, and you have an interactive analytic application suggested by our suggestion engine that you can then style and make your own. This is one of a number of investments we've made. We've also got an NLQ engine where you can have a conversation with Spotfire and have that also generate the suggestions that you can point and click into the dashboard. So a big area that we've invested in here, a number of other things, the UI making it easy for people to adopt, automatic data wrangling so that as you can see that as you create your visuals for the analysis, we're keeping track of everything you've done in a full data lineage. And then we've brought in also real-time data. So right outside the booth, if you go sit in that car out there, the Mercedes F1 car, and you drive it, you'll see the real-time data coming onto the screen as we track how you take a corner, what the pressures are, the forces are, and you'll get a taste of what we do working with the Mercedes F1 team to bring real-time insights to the F1 racing series. So a pretty big release. We just announced it today, actually, so you can see it on display in the booth. Now, what's happening under the hood? Like I say, when the data are connected into Spotfire, we start at the top, and the first variable we make is the Y variable. All the others are the X's. We fit a model to find what's related to that Y. We go on to the second variable, that becomes the Y, and we systematically go through and fit an association model to understand all of the relationships between the variables. So by the time I click here on this life expectancy variable, I've probably already created the model for that, and now I can show you what is related to that in order of strength of the relationship and with the appropriate visualization that displays that relationship. So scatter plots, density plots, whatever the case may be, I have figured out for you what is related to this variable, and I'm now suggesting to you from our suggestion engine what we think would be a good set of graphs to have in this brush-linked dashboard. Now, we go a little bit further than that because you can also type, so you don't have to click. You can ask Spotfire a question and say, hey, is there any information in this data about how revenue is trending over time for a certain region? Spotfire will interpret that into a set of questions. It'll find if that structure exists in the data, and it will then again display those in order of strength, the relationships that you've elicited through a typing interface with the software. So the NLQ and the AI engine work together in that way. Now, the idea of this is to broaden our user persona that uses the software. So really all you have to be able to do is click a mouse and decide what you're going to put into the analytic application, and you're able to use the software. So I'm going to just show you a couple examples of this. This is Airbnb data from New York City, and a couple of clicks you can show price is the target variable. We've found that price varies as a function of room type, as a function of location, and you get a map, and you can basically link between the different room types, show where they are in the different locations. When you click and enter something into the dashboard, it's automatically brush linked across the different visualizations. Another example here is Telco Churn. So now I'm clicking on customer status is the variable here, and I can see that the churners have a lot more conversations with people who've already churned. So we're looking at conversations of one subscriber to another, and if the other subscriber, is pissed off with AT&T or whatever, they'll infect the person that they talk to, and you see that varies a little bit with handset. But here are the actives, here are the churners. Here are the churners, here are the actives. The churners have much more number of conversations with these infected people than the actives. Now, Spotfire is also, I guess, the video's already played, but we figured out that there's also charges that you've got on your card. Stand back here a little bit. So extra charges that you have on your card there are also a contributor to you churning. So basically, if you've had a bunch of charges beyond your monthly plan on your card, and you've been talking to somebody who's also pissed off at the company, your propensity to leave the company goes way up. And so Spotfire is able to, as you saw in the sequence there, I couldn't speak fast enough to keep up with it, but I found the pattern of the actives versus the churners, the extra charges on the bill, the conversations with the other churn customers, and in a few mouse clicks, I've been able to build a dashboard that finds the insights around the propensity to churn. Okay, so, sorry, here we go. I'm going to build this right now. So that was a screenshot. Here we go. So I'm going to click on customer status, and let's see what we get here. Spotfire is suggesting this churn chat, and it's also suggesting this extra charge for calls. I'm going to flip this across to side-by-side bars. I'm going to see the churners up on the left there, the actives on the right. Now, the extra charge for calls is on the y-axis here. Churners are in red, actives are in blue. I'm going to now style this to put the drawing order, to put the churners on top. Now, it still doesn't really show me. Let me switch this to a log scale. It's still not going to show me exactly. There's a bit of overlap here. So I can go back to Spotfire and say, hey, show me some more recommendations like this one, but maybe choose a different graph type that allows me to distinguish the actives from the churners a little bit better. I'm going to click on this density plot now, and you see now that I've got the actives and the churners separated, so they're not overlaying on each other and clouding the issue. And now I've got the extra charges for calls on the x-axis, the chatting with the churners on the y-axis, and now I can find the action in the data. So literally 3 mouse clicks and a little bit of styling on the graphs, and I've got that analysis. Now, in terms of the NLQ I mentioned, I can start to have a conversation with Spotfire. So let me start asking some questions. This is beverage data from the Bay Area, and I'm going to ask Spotfire, show me the categories of beverages. I'm going to see some hot beverages here and some cold beverages here. So this is a distributor who's, and I'm asking it, which types of coffee do we stock? I can see a quick view of coffee types. So if I restructure this and turn some things on their side here, make these side-by-side bars rather than stacked, turn this to a horizontal, do it stacked as proportions, turn it to horizontal, and I can see my top American, dark roast, decaf, Ethiopian ground. These are the different coffee types I have in this distributor's collection of products. Find me the popular brands. Spotfire sees popular and converts that into frequency, sees brands and puts that on the other axis. I'm going to now limit that down to the top 10 or so brands, get rid of the tail there, flip it around to be horizontal. And now I can see my top brands are things like Uluru and Spencer's and so on, different brands of coffee. I can slide these around a little bit and make it more appealing as to the layout and the interactive sequence that I want to have the user to use here. And now I'm going to start asking a couple more questions here. Let's see, how about what is the Palo Alto sales? What are sales of the different brands in Palo Alto? Spotfire sees Palo Alto, sees revenue, and by time, sees time. So it's now converting those into what columns might exist in the data, and it's showing you a line chart of revenue for coffee sales in Palo Alto. It's automatically compressed and hierarchy the time so that you've got year and month, and it's showing revenue on the y-axis. Now it's saying, show me some more about Palo Alto. So it's going to show a little bit more drilling down on this particular graph, and it's seeing some relationships with sales for other nearby regions. So I can see the relationship of sales across time between San Jose and Palo Alto. So a couple more clicks and I can add that into the dashboard. So at this point I've literally asked 4 or 5 questions in natural language, and I've constructed an interactive dashboard. And here I can start to play around with this. I can style these graphs a little bit more, get rid of redundant legends and that sort of thing. And I put my navigation bar chart in the top left-hand corner and start to interact now with the dashboard. As I mentioned, the dashboard is automatically brush linked. So as I click on one area, you'll see it highlighted in another area. And so here I can see that dark roast is the popular coffee for folks who are working in San Jose and Palo Alto. It's usually the strongest. People have to stay awake longer to write more code. So this is the trending coffee type in Palo Alto. So literally 5 questions and brush link dashboard results showing you this structure in the coffee sales in the Bay Area. So what we've done under the hood here is, as the data comes in, we do a little bit of data prep. We figure out, for example, with time, do we want to put in a column for month, a column for year? What do we want to put in as the features in the machine learning model? We base that on the span of the data. We do a little bit of binning, and then we fit the algorithm, come back with the ranking of the relationships, and then we present those to you in order of their strength. It's a non-parametric test statistic that's robust to sparsity in the data and any distributional assumptions. And now I click that into the dashboard, but that's the starting point. I can now add curves to that or do whatever I want to elucidate that relationship that's been suggested to me by the suggestion engine. So this is all going on behind the scenes. You're seeing the actual data. We're doing a little bit of feature engineering behind the scenes. We don't really show you that to you automatically, but you can now continue your journey to adorn, manipulate, explore, and drill your way through the data. Okay, so that's case study number 1, recommenders. Really big success story for AI in general and how we've adopted that into our product at TIBCO. Okay, next case study, a success story in AI's anomaly detection. Very general problem, and we use this in Formula One. We use it in oil production, surveillance, predictive maintenance, manufacturing, financial services, trade surveillance, fraud detection, healthcare and pharmaceutical. And the whole idea behind this is to understand variability. If we want to kind of keep the variability low, then we can understand what's an anomalous observation compared to the historical range of the data. Now, as you know, Lewis won the championship a couple of weeks ago, and then on the weekend, we won the car constructor championship as well. You'll see this outside. You can jump in the car. You can simulate a drive around an F1 track. But we're very excited about the partnership that we have with Mercedes, and a lot of it is based on anomaly detection. So how do we get data from the car? We get about half a terabyte of data per weekend from the 2 cars. And we're looking at things like outings, the tire type, the tire condition, the lap and sect of the car position. We're getting GPS data down in the centimeters, and we're able to analyze each race and figure out what we want to do in the next race in terms of the car setup, for example. So in between each race, 2 weeks apart, we do a couple of million simulations and different configurations of the car. And we figure out what's our strategy for the race, when we might want to overtake another car. So we have a machine learning model for figuring out what position on the track, what's the latent speed differential, what tires do we have on versus the car in front, what's the age of the tire of our car compared to the tire in front, and we figure out what could be a good place on the track to do an overtake under certain conditions. Now we also do a bunch of R&D testing. Folks who are in hearing Matt talk this morning, the gearbox is something we want to really get a handle on. Lewis changes gears about 3,000 times per race. We want to figure out if he can do that at different parts of the track, if he can do that at speed with the throttle on or with the throttle off. We get data, it takes a couple of milliseconds to change gears. We get data every few nanoseconds, and we look at 300 variables, and we figure out what the anomalies are in the setup of the gearbox, and we trap the configuration of the gearbox to lower the chance of having any anomaly when he changes gears. So that's something we do in the R&D testing, and then, of course, we do the strategy and the analysis through the simulations to figure out how we're going to approach the next race based on the configuration of the car from the previous race and the races before that. Now, these cars are pretty amazing. This is a prototype you see outside here, but we have to keep these cars on the ground, otherwise they would fly. So we figure out how to optimize the downforce in a variety of R&D runs we do for aerodynamics and so on. So that's another set of simulations that we do around the car setup. And then, basically, here's an example. I was fortunate enough to go to Barcelona. I sat right at this part of the track here where you can see the overtakes occurring. And if we can run this video, I was able to get a bit of a first-hand look at how overtakes occur. At least that was my excuse for getting the pass to go to the track. That was what I told my management. I need to actually observe this model, firsthand. And then they bought that, and they also let me go to Monaco. And just to show you how quick it is that we change the tires, here's I got a seat right above the pit stop in Monaco. So 1.8 seconds to change 4 tires on the car. It really matters. Every 10th of a second, every 100th of a second. In qualifiers on Friday, every 100th of a second matters. To get pole position, you're really competing down at that level of speed. So, yeah, pretty excited about the work that we've done here. You can read about it. There's an article in Forbes on Lewis, the work we've done in using analytics to build up the strategy of the race. There's a French version of that as well. So anomaly detection is a big deal for us, and it's part of the work that we've been doing with Mercedes. Now, we didn't learn how to do this with Mercedes. We've been in partnership with them for the last few years. We learned how to do this in various other industries like oil rigs. So if you look at data coming off of an oil rig, you're getting, for the high-producing wells, you're getting electrical parameters, downhole pressures, temperatures, surface pressures in real time coming off of these wells. And we monitor those data 24/7 to prevent failures, extend the equipment life, enhance production, that sort of thing. And if you look at the data coming into our Spotfire tool, these are the various pumps here on the top line. We've found some anomalous behavior here. The blue curve there is pressure. So when pressure spikes like that, typically there's a blockage in the downhole or a pump or a tube that gets blocked. This causes the pressure to spike. And the current typically goes down at the same time. So this is a classic anomaly that we've been able to detect on a historical well. And we basically set up a model that will predict that as the pressure starts to rise and the current starts to go down, we can take an action. Now, of course, we want to backtest that on all of the data history that's available to minimize any false positive rate. We don't want to be alarming people about an anomaly that may not be of interest. And we calculate control limits, we fit some rules and models, and then we put that out into our real-time view that we have in Spotfire. And so as the data are coming in from the sensors, from the equipment, we clean the data, we calculate the features, we test the features against the thresholds, and if there really is a problem, we'll send a notification or an action to go and shut down that pump. Now this is a basic anomaly detection that we do here, and we are preventing this occurring. So when this occurs, the well goes offline for several weeks, no oil, and it costs quite a bit of money to retrofit and get that back up and running. So lots of money saved in this area. Now, in addition to doing production surveillance, back into the control center, typically in Houston, we also do some edge analytics. So when you're drilling, you want to take the action right at the drill site. So when you're bringing in data, and here's your plan trajectory here in the black, here's your actual trajectory in the red, there's a gap. We have figured out in Spotfire how to address that gap. It's kind of like you drive off to your friend's place, think you know where you're going for a party, and you get lost, and then you turn on the navigation system, and you optimally bring yourself back to the planned trajectory. That's the bit that we do there. And we do this at the edge, right when the data is coming off the drill rig. So this also is a big money spinner. Billions of dollars of savings involved in optimizing drilling. When the New York Times wrote this article, they asked me about, so this is saving us billions of dollars, Michael, how much do you charge for the software? I had to bite my tongue. I was going to say not enough, but I thought better of that and ended up declining to discuss the pricing because obviously we charge in the thousands and the companies are saving in the billions, so it's a little bit embarrassing to not extract the value from our software here. But in terms of understanding variability, You can do basic control charts, but we've been lately doing these autoencoders. So if you think about data coming in one row at a time, and we've got a hidden layer here in the middle, if you've got 100 dimensions coming in, we approximate that in 10 dimensions, then the observations that are not very well approximated are probably outliers. The ones that are well approximated in the body of the data are not going to be anomalies. So you can start to plot this reconstruction error versus time. You can spot the anomalies, and then you can drill down to find a root cause. And we have these available as templates on our Spotify website. Now, we apply this to other sorts of equipment monitoring. So in high-tech manufacturing, we get a view of the manufacturing facilities, a view of the factory, and a view of the actual real-time data coming off the equipment. And we can start to apply these same anomaly detection techniques to that sort of data. And as I mentioned, there's a download that you can get to add into Spotify for this type of analysis. Okay, so that's the second case study, anomaly detection. Now, the third case study here, before we wrap up, patient diagnosis. So this is some work we've been doing with the University of Iowa, and they have identified an area that is really significant in terms of cost to the system, and this is surgical site infection. So really high cost in terms of a hospital-acquired disease, and we focused on that because of that, and this program is able to produce a 74% reduction in surgical site infection over 3 years, saving quite a chunk of money. And what we've done here is to take data from the OR on the top row, along with data from the electronic medical record, combine those together into a predictive model, and we found that some of the variables that were predictive, like duration, EBL, ostomy, transfusion, wound class, these are collected in the OR in real time. Another example of how you need that real-time data to get a good prediction. Some of the other variables that are predictive are from the electronic medical record, but basically, bottom line, we came up with a good model that predicts the surgical site infection probability, and we're now rolling this out. We just got approval from the CDC to roll this out to 6 other hospitals as part of a CDC grant, and now we're going to start to collect data from the various hospitals and centralize that and borrow strength to provide input into the statistical model. And this has been written up recently, and we're pretty excited about this case study. And I guess I have one more case study before I wrap up. This is a really nice, heartwarming story of AI for social good. And we got involved with the San Francisco Transportation Authority, and the Office for Financial Justice was a collaboration with a nonprofit Tipping Point, and we were studying parking citations and their effect on low-income people. And I've got first-hand experience of this. My daughter's not very good at parking, avoiding the street sweeping, and I get these fines, and then if I don't pay the fine within a few weeks, it doubles, and all of a sudden you've got, I didn't get into this state, but you've got a $1,000 bill on your hands, and if you don't have a lot of money, that can be a problem. So basically, we pulled this data into our TIBCO data science product. We collaborated with Tipping Point. Here's the leader from the Tipping Point nonprofit group. This is a very collaborative tool. It's like having Facebook combined with data science. You can see what everybody's doing. Ashley wasn't actually analyzing the data, but she was giving direction to the data science team about how to analyze the data. And we brought the data in. We found some different data that we joined together. One of the key findings or key features that we engineered was we found the license tag on the plate related to the age of the car. And so we're able to look at the citations, bring in the age of the car into this, and we found some really interesting things going on. So here's where we joined the data from the license tags into the rest of the car. And now we brought the data from our data science product into Spotify. We started to find the different neighborhoods. Red here are the most expensive neighborhoods. White are the least expensive. I live right around here. Anyway, so we then brought in the data for the age of the car and the make of the car, and we found that the violation amount was related to the make of the car, the age of the car, and the neighborhood of the citation. So we pride ourselves in San Francisco on not discriminating, against people, but we found that certain parking officers are discriminating against the age of a car. And if you look at the same citation, so the average ticket cost for plates, $110, and for the older cars, $136. Every citation we looked at was higher for older cars than for newer cars. So there's some bias in the parking officers who are writing out these citations in different neighborhoods. So we took this analysis to the Metropolitan Transportation Association of San Francisco, and they were very data savvy, and lo and behold, they agreed with this. And so they put in place a policy where if you had an old or delinquent ticket, you could get the late fees waived. They put in place a payment plan program. And then finally, they put in place a community service program so that if you qualified, you could actually do community service to work off your fine. So I'm an old guy. I've been doing data science all my life. This is the most impact I've ever had on public policy just by showing a good data science analysis, finding a real problem, and having a policy organization like the MTA listen to us and actually change their policy. I'm really excited about this. Okay, so that's kind of it. I've tried to cover a few case studies here of the successes in AI and how we've been investing in those at TIBCO. Again, the big investment that's come out today is this new Spotfire 10 with the AI-powered AI engine inside of it with NLQ, real-time data, reimagined interface. And you can bring this, you can subscribe to this in the TIBCO cloud, or you can buy it and bring it on premises with, if you're in the cloud, you get other products to go with it. You get templates around how to do, say, anomaly detection in the cloud or on premises. You can download these and apply those with your Spotfire and other TIBCO products. And there's a community site where you can learn all about how to do this. On the left-hand side is our community site. On the right-hand side is our partner's community site. And that's about it. Follow me on Twitter. Send me an email. And thanks for your attention.